So today's question was cherries pick 2. So in this question what we have to do? We have given a grid. A 2D matrix, basically a grid in which each cell denotes the number of cherries present in the field, in that respective field. So basically each cell in a grid is corresponding to a field, and the value present in that cell is equal to the number of cherries that are present in that field. Next, we are given two robots. One robot is on the cell 0, 0, and the second robot is on the cell 0, cols minus 1. Okay. Now the robot is allowed. So what we have to give, what in the output? We have to return the number of maximum cherries picked by the robot A and robot B. So what are the conditions? First, the robot can move only in the direction in the, like, if it is present in I comma j cell, then it can move to I plus 1 comma j cell, or I plus 1 comma j minus 1 cell, or I plus 1 comma j plus 1 cell. Basically from first row to second row, and from jth column to j minus 1, j or j plus 1 column, the robot can go. And in whichever cell the robot goes, it picks all the cherries from that cell and then put it in the basically the result. And if the cell in which the robot comes, and if in a cell that there is a cell in which both robots come, so both robots are present in that cell, so only one robot can pick the cherries from that cell, and the second robot cannot pick the cherries from that cell. So here what we are doing is we'll start with like recursive solution. Like we can make the base conditions like the both robots cannot go less than equal less than 0 index, or cannot exceed from the columns, so it have to return 0, or the condition would be like row equal to grid dot length, so it will return 0. So these are the base condition, and the second one will be like whatever the robot is present, pick that cell, put it in the result answer, put it in the result value, and then make two nested for loops in which the robo 1 is going from for the first column for the second column, and then make the max element, call the function recursively and get the max what both robots can pick from that row, add it, and then at the end result return the answer, but it will give the TLE. So what we'll do is we'll start DP because we are finding the overlapping problems. So for overlapping problems we can store it in a DP. So basically there are three variables that are changing: the number of row, the number of column for the first robot, and the number of column for the second robot. So we have to take a 3D array, 3D vector matrix, in which we'll store the answers, and then if the answer is already present, it is an overlapping problem, then we can easily use it. It's a basically top down approach, and from this we can optimize it, and we are making it faster. So hence it's a solution. It's a hard problem. Yeah.